Today we're going to focus on parallel lines and the angles that are associated with those. So let's start with a definition. Two coplanar lines are parallel if they never intersect. And of course, this word is very important. That means that they lie on the same plane. So you could think of it as like a board or a wall or the ceiling or the floor. Those are planes. And if two lines are on those planes, think of like putting two rulers on the floor. If those went on forever and ever in both directions and they never crossed, they would be parallel. In 3 space, though, I could hold up two rulers, one in each hand, and they could not intersect, but they may not be parallel. So it's important that they're coplanar. All right, so for example, I have a picture here of some parallel lines, and the blue lines are all parallel, and the notation that we use to show that they're parallel are these little red arrows. And let me make my own arrow so I can point to these. So these little arrows mean that these lines are all parallel. And notice the green lines also have arrows, but since I already used a single arrow, I'll use a double arrow for these, because if I just used a single arrow, that would mean the blue and the green are parallel, and that's not true. So you can use, 1 or 2 or 3 or whatever little arrows on your lines to show that they're parallel. Now the notation that we use to say that lines are parallel is the following. So for example, I could say that line M is parallel to line N. So we use those two diagonal slashes together, and that means parallel. Likewise, for the green lines, I could say line J is parallel to line K. So that's the notation we use to represent parallel. Those are the symbols. All right, so if we have two parallel lines, like the blue ones here, these two blue lines I know are parallel because they have these matching red arrows, so those are parallel. And then if I intersect those parallel lines with another line, and that other line is called a transversal, I wind up making 8 different angles between the transversal and the two parallel lines. And we have special names for certain pairs of them. And so once again, we're staying with the theme. We're dealing with pairs of angles. So 2 angles. Now we've already talked about, notice there's 2 groupings. 1, 2, 3, and 4 are all together, and then 5, 6, 7, 8 are all together. We know that 1 and 4, we call those vertical angles, and they're equal. 3 and 2 are also vertical angles, and they're equal. 1 and 2 form a linear pair, and they make a straight line, so they add up to 180. So we have names for those that are together, across from each other or next to each other. But now what I want to do is I want to talk about one angle from this group and one angle from that group. Those are the pairs that we're going to be focusing on. So remember that. It's one from this group and one from this group. So the first type is called alternate interior angles. Now, these words are important. So alternate means opposite. So that means that we're picking angles that are on opposite sides of this green line, this green transversal. Interior means that they have to be in between the two parallel lines. So we're looking for 2 angles, one from this group, one from this group, that are on opposite sides of the green transversal, and they're in between the blue lines. Well, we have 2 choices. We could say angle 8 and angle 4. They're between the blue lines, so they're interior. They're on opposite sides of the transversal, so they're alternate. So angle 8 and angle 4 would be an answer. And then also angle 3 and angle 5. Those are alternate interior angles. So we have 2 pairs of alternate interior angles. How about alternate exterior angles? Well, the same logic applies. This time, alternate once again means opposite sides of the green transversal. Exterior now means that they are outside of these 2 blue parallel lines. So they're not in between, they're on the outside. So we're looking at these angles out here, 1 and 2, and these angles out here, 6 and 7. So we want them to be alternate, so for example 7, and then I have to go across the transversal to 2. So 7 and 2 are a pair of alternate exterior angles. Likewise, angle 6 and angle 1 would be alternate exterior because they're on alternate or opposite sides of the green transversal and they're outside the two parallel lines. So we have two pairs of alternate exterior angles. The last type are called corresponding angles. And this is the one that throws students because we're not using these terms alternate or exterior, interior. And the reason being is because they're both not alternate. So that means they must be on the same side of this green transversal. And we're not using interior because they're both not inside, in between the blue lines. And we're not using exterior because they're both not outside of the two blue parallel lines. That means that one must be on the inside, and then one must be on the outside. So we're looking for two angles, one from this group, one from this group. One of them is in between the two blue parallel lines. One of them is outside the two blue parallel lines, and they're on the same side of the green transversal. So for example, let's start with 7. That's outside, so I need to pick one that's inside from the other group, and it has to be on the same side of the transversal. So that would be 7 and 3. Likewise, I could pick 6 and 4. 6 is outside, 4 is inside, and they're on the same side of the green line. So we've got 7 and 3 as a pair. 6 and 4 are a pair of corresponding angles. We could do 5 with 2. 5 is inside, 2 is outside, and they're on the same side of the green line. And we could also pick 1 with 8. 1 is outside, 8 is inside, and they're both on the same side of the green line. So we actually have 4 different pairs of corresponding angles. 1 and 8, or 3 and 7, or 2 and 5, or 4 and 6. Now why are these pairs very special? And one thing I can't stress enough, remember, for all 3 of these, one angle comes from this group and one angle comes from this group. If both angles came from the same group, we've already talked about those. We know they're vertical angles or they're a linear pair. All right, so now what's so special about those? Well, we have 3 theorems. If we have 2 parallel lines cut by a transversal, like that last example, then the alternate interior angles are congruent. Let's go back to that picture. That tells me that angle 4 is congruent to angle 8. Angle 8 and angle 4 are congruent because they're alternate interior angles. We also know that angle 3 is congruent to angle 5 because those are also alternate interior angles. Use a different mark for 3 and 5. So alternate interior angles are congruent. The next theorem says if 2 lines are parallel, cut by a transversal, then the alternate exterior angles are going to be congruent. Let's go back to that picture. So this is telling us, hey, once we identify the alternate exterior angles, get out of there, 2 and 7, 1 and 6, we know those are congruent. So angle 2 is congruent to angle 7, and angle 1 is congruent to angle 6. So angle 1 is congruent to angle 6, alternate exterior. But wait a minute, 1 and 4 are vertical, so I also know that 1 and 4 are equal. So I'm going to use the same mark on 1 that I did on 4 and 6 and 8. So that actually tells me, because of those 2 theorems, that 1 and 4 and 8 and 6 are all the same. So if I tell you angle 1 is, let's say, 110 degrees, you already know this is 110, that's 110, and that's 110. And we also know, so let's see, 1 and 6, we also know angle 2 and 7 are congruent, because those are alternate exterior. But 7 is congruent to 5, because they're vertical, and 2 is congruent to 3 as well. So if you look, we have marked all 8 angles with only 2 different markings. 4 of the angles have these double purple marks, so angle 2, 3, 5, and 7 are all equal, and 6, 8, 4, and 1 are equal. And then the last theorem says corresponding angles are congruent. So it says 1 and 8 should match. Well, look, 8 and 1 have the same mark. 3 and 7, 7 and 3 have the same mark. 6 and 4, 5 and 2. So if we have 2 parallel lines cut by a transversal, out of those 8 angles, there's only 2 different measurements. And I guess they could actually all be the same if they were all 90. And so that was our last theorem, is that the corresponding angles are also congruent. So let's go to a picture and see how that helps us. Find the measures of all the other angles. So as you can see, I have a little arrow here. We have 2 parallel lines. These blue lines are parallel. That's what these red arrows are telling me. And then I have this transversal in green. And they've given me 1 angle. So let's start marking the rest of the angles. Well, if that's 110, I know the one across from it is also 110 because they're vertical angles. And I know that this angle and this angle are alternate interior, so they're going to be the same. And then I also know that this angle is vertical with that, so those are all going to be 110 degrees. Now let's figure out the other ones. Well, these two, for example, make a straight line. So I know these two are a linear pair. So if this is 110, if I subtract that from 180, I'll get this angle. So this angle is going to be 70 degrees. And likewise, if that's 70, it'll be vertical to this one, so that'll be 70 as well. And then I know that this angle and this angle are alternate interior angles, so they're going to be equal. And then likewise, I have a vertical angle for that right over here. And so now notice, all they gave me was 1 angle out of the 8, and I know all the other angles now. So if the terminology, those names, alternate interior, alternate exterior, or corresponding, if that's still a little confusing, with some practice you'll get to know those pretty well. It's not too difficult. But the most important thing to understand is because of all those theorems and those names, we have these two and these two. These 4 angles here in black are all the same whenever you have 2 parallel lines cut by a transversal. And then the other 4 angles are also all going to match. All right, so one of the worksheets for homework is worksheet 3A. And I have 1 or 2 more examples. What if I don't tell you the lines are parallel, but I give you some angles? Well, what I like to do is fill in what I know. If that's 132, I know it's alternate interior with this one. So this should also be 132, if they were parallel. But I don't know they're parallel, so I can't go with that. So what I'm going to have to go with is what I do know, is that's a linear pair. And so if I do 180 minus 58, I get 122. This angle is 122 degrees. Oh, if these 2 lines here were parallel, this angle should match this angle because they're alternate interior. And they don't match. So therefore, I know that these lines cannot be parallel. because if they were, the alternate interior angles would be congruent. And one last example. What if I give you this picture and it says if m is parallel to n? So they're telling us that these are parallel. If that's true, figure out what x is. All right, so we look at the picture and we say, well, let me mark an angle. I'll start with this angle. That angle is going to be congruent to this one, is congruent to this one, is congruent to this one. So I can write equations and I can say 7x minus 2 is equal to 6y plus 8. But notice this has an x and a y in it. So maybe I don't want to do that one. I could also say 6y plus 8 equals 8y minus 22. Well, I can solve that one because they both have y's in them. And then I also could have said the corresponding angles are congruent. But once again, one has an x and the other has a y, so I probably don't want that either. So this is the one I'm going to use, and when I solve this, I'm going to get y is equal to 15. Now, it said find x, so I'm not done. But now that I know y is 15, now I can use this equation. And I'll plug 15 in for y. So I'm going to have 7x minus 2 equals 6 times 15 plus 8. So 7x minus 2 equals 98, if I simplify that. And then I can add 2 to both sides. 7x equals 100. And so divide by 7, I get x equals 100 over 7, which is some decimal number, so I'll just leave it as a fraction, 100 over 7. All right, the second part of the homework is worksheet 4.